Good morning, students. On today's lecture, I'll prove one of the famous theorem that you have learned already in your classroom, Pythagorean Theorem. Pythagorean Theorem says that if you have a right angle triangle ABC, in this case, B is my right angle, that means equal to 90 degree. Opposite sides of angle B is known as hypotenuse. Now, Pythagorean theorem says this hypotenuse square equal to sum of other two sides square. The way I have written it, all the vertices are represented by the small capital letter like A, B, and C, and their opposite side, like for an example, angle B is represented by the capital letter of B. Now, opposite side of B is AC, and that represented by a small letter of B. So this one is opposite side of B, B square equal to sum of other two sides square. Now the proof I'm going to do, that's actually, this proof was done by James Garfield. I'm not sure if you heard this name or not, but believe it or not, he was a former United States of America's president. Okay, he was a president of United States of America. He has proven whatever I'm gonna prove today, same proof. Okay, he has done it when he was in his university life, and he was the only president who ever come up with a mathematical proof of a theorem. Okay, so this is very unique. I love this proof. It's very interesting and very easy to understand. Okay, to do that, I have just cut two of the triangles. Okay, same size, so they are congruent. And as you can see that this is a right angle and this is also a right angle. The reason I have made two of them, you're gonna find out in a second. Okay, now the way I have drawn this triangle over here, I'm gonna use the same thing. Now this base BC is represented by A, and this hypotenuse is B, and that one, this perpendicular line is C. I'm gonna do the same with this one. They are congruent. So this is right angle A, B, and C. And one more thing I'm gonna do, this angle, I'm gonna represent that by theta. Okay, this angle is theta. Now you know that sum of three angles equal to 180 degrees. Sum of three angles of a triangle equal to 180 degree. This is already 90 degree and this is theta. So if I represent this one in terms of theta, this is gonna be 90 minus theta. I hope you understand that. Okay, so this is theta, same thing. See, this is theta, and that's gonna be 90 minus theta. And the way I'm gonna do, I'm gonna place this one, and let me have a scale over here. Okay, so this one, I'm gonna put it right here. Actually, let me take a bigger scale. Okay, I'm gonna take a scale, and then I'm gonna draw a line over here. Okay, and on this line, let me put a point. Okay, so this angle is supposed to be a straight angle. Okay, I can name that A. Well, actually I have A, so let me put M, N, and this particular point O. I'm gonna put a little off from here, and see that if I put it here like this, okay, like this against this line, so this base of this triangle, the paper cutout, that triangle coincide with this line. Okay, and now if I slide it over here, okay, see that it was like that, and if I slide it like this, this line is coincide with that. To show you this, I have made two of them. Okay, that's the reason I have made two congruent triangles like this. So this one and the top one, I'll just slide and I put it this way. Okay, if I put it this way, see, same triangle comes over here, and this theta goes over here, this angle, and this 90 minus theta comes over here, and right angle over here. So these two are parallel. Okay, so let me draw this. Okay, just draw this one. This triangle is something like this, and then this one gonna be something like this. Okay, so that's that. And when I did this, this one was theta, and that one was A, this is B, this is C, and that was 90 minus theta. I don't need that, but just to show you how this thing works. And this one was 90 minus theta. So this particular place is 90 minus theta. This is this, and this is theta. And when I do that, this is C, this is A, this is B. Okay, so that's all I need over here. Now what I'm gonna do, I'm gonna join these two vertices. Okay, let me write down the name of this. Okay, so over here, opposite of A is capital A. Now opposite of B, this point is gonna be B. Let me just extend a little bit for M. And this one, A, B, this is C. Now the same thing, same triangle, when I fold it, put it like that. So this is gonna be A, and A is opposite side of this, so this is gonna be A, this point C and A, because from here I don't need this, but just to show you, B and this is gonna be C. Okay, so it's like that. And if I join these two vertices, this triangle's vertex and this triangle vertex, if I join that, then look what happened. This thing, A, B, and B here and C, this does look like a trapezium. Okay, now this trapezium, let me put it this way, area of the trapezium equal to, okay, this area of the trapezium, we know that area of the trapezium is half into sum of parallel sides into height. Okay, we know this. Now area of this trapezium, okay, I'm gonna put this area 1, area 2, area 3. So this area of the trapezium has to be equal to area 1, area 2, and area 3, sum of them. So instead of this, we're gonna write down area 1 plus area 2 plus area 3. Okay, and over here I have this half. Now sum of parallel side, these two are 90 degree each, so they are perpendicular to this horizontal line, so these two are parallel. Now sum of this parallel line, A plus C. So let me write down A plus C. What about the height? Now this cannot be height because it's not uniform. So if I take it this way, this is perpendicular to this. Okay, so this must be the height, and height you can say that A plus C. So that's gonna be A plus C. Okay, so if I wanna put the areas formula for this area of one, triangle 1, area 1. So ABC, we know that this is perpendicular, so we can use the formula half base into height. So let me put half, base is A and height is C. Okay, now area 2. Area 2, well, I don't know if this is a right angle or not. Okay, so let me see what kind of angle is this one. This angle, okay, let it be theta. Now you know that, I hope you know that, okay, if this is a straight angle, okay, remember I put MON, that was the reason I put this 3 letters over here, MON, and this is 180 degree. So every, doesn't matter how many angle you draw on this side, okay, on one side of the straight line or horizontal line, okay, in this case horizontal line, every angle that you draw, if you take all of their sum, that sum has to be equal to straight angle, that means 180 degree. Now in this case, this theta, okay, I have this theta, I'm gonna take this one alpha. Okay, so this is the horizontal line, and this MON, this is 180 degree. So summation of theta plus alpha plus 90 minus theta must be 180 degree, right? So theta plus alpha plus 90 minus theta has to be 180 degree. This theta cross out. Okay, so this alpha, if I take it that side, see that 180 minus 90, so that's gonna be 90 degree. So instead of this arc, I'm gonna put this square, small square, and you know that small square represents that this is a right angle triangle. So when this one is a right angle triangle, I can write down area of the triangle. Let me write down area of the triangle. If we have the base and height, perpendicular height. So you can write down half base into height, right? So this base over here is going to be b and height is b. So in the place of that, area of 2 half base into base plus area 3. This is the same area of that one, congruent. So this area must be equal or half base into height. So I'm going to put half base into height. See, I wrote down AC, so I'm going to write down AC. And this one over here, half a plus c square. Okay, a plus c times a plus c square. If I take half common from here, here, so if I take half common, that's going to be AC plus, this is going to be b square, is b times b is b square plus AC equal to half. And this is the formula of a plus b whole square. Okay, I hope you know that one. A plus b whole square equal to a square plus 2ab plus b square. And in this case, in the place of b, I have c. So b will be replaced by c. So this is going to be a square plus 2ac plus c square. Now this whole thing is multiplied by half, and this whole thing is multiplied by half. So I can cross this half and half out. Now what do I have? I have 2ac, see that, 2ac plus b square, and over here I have a square plus 2ac plus c square. Now this ac, this ac, that they are on the both side and their sign is positive, so I can cancel this out. Okay, if I cancel that out, then what I have end up with, b square equal to a square plus c square. Now this b square equal to a square plus c square is the theorem, that Pythagorean theorem we had, b square equal to a square plus c square. See that these two are equal. Okay, so this is the proof of the Pythagorean theorem. I hope you love it. I loved it. Okay, James Garfield, he did this algebraic proof. It was very neat, very nice, and very innovative. I love this one. I hope you do the same. Okay, it's better to know, it's good to know this formula, where it comes from. Okay, there are so many other proofs, but to me this is the best. Okay, if you know other proof, you can compare with this. Okay, I love it. I hope you enjoyed that too. Okay, that was it for today. Thank you very much. Have a good day.